Log scaling is the first step in the sawmilling process at Collins Lakeview Sawmill. This crucial stage involves measuring and estimating the volume of incoming logs to determine their value and optimize their use. Skilled scalers assess each log's diameter, length, and defects to calculate the board foot volume using industry-standard scaling rules, such as the Scribner, Doyle, or International Log Scales. At our sawmill in Lakeview, Oregon, log scaling ensures efficient use of white fir and ponderosa pine by classifying logs based on their size, quality, and potential yield. Advanced digital scaling systems may be used alongside manual measurements for greater accuracy. The scaling process helps in sorting logs for the best utilization in producing dimension lumber, commons, and industrial-grade wood. Debarking is the process of removing bark from logs before they enter the sawmill for cutting. At Collins Lakeview Sawmill, a high-speed mechanical debarker strips away bark to improve sawmill efficiency, protect cutting equipment, and reduce debris. This step also prevents dirt and grit from dulling saw blades, ensuring cleaner cuts and higher quality white fir and ponderosa pine lumber. The single-pass saw is designed for efficiently processing smaller logs by converting them into lumber in just one pass. This high-speed cutting system optimizes yield by minimizing waste and handling time. The head rig is a powerful primary saw used to break down larger logs into cants or flitches for further processing. It handles oversized white fir and ponderosa pine logs with precision and efficiency. The resaw is a crucial machine in the sawmill process, used to further refine cants or thick slabs into thinner boards. At Collins Lakeview Sawmill, the resaw ensures maximum recovery from each log, optimizing the production of dimension lumber, commons, and industrial wood. By making precise, high-speed cuts, it enhances efficiency while minimizing waste. This step is essential for ensuring uniform thickness and quality in white fir and ponderosa pine lumber. The curve gang saw is a high-tech sawmill machine that maximizes lumber yield by following the natural curvature of a log. At Collins Lakeview Sawmill, this saw efficiently cuts white fir and ponderosa pine cants into multiple boards in a single pass, reducing waste and optimizing the production of high-quality lumber. The egger is a critical machine in the sawmill process that trims rough-cut boards to create clean, straight edges and uniform widths. After logs are broken down into flitches or cants, the edger removes irregular or wavy edges, ensuring each board meets precise size specifications. At Collins Lakeview Sawmill, the edger processes white fir and ponderosa pine boards efficiently, maximizing lumber recovery while minimizing waste. Some edgers use laser or computerized optimization to determine the best cutting lines, enhancing accuracy and yield. The bin sorter is an automated system that organizes lumber based on size, grade, and species after it has been cut and processed. At Collins Lakeview Sawmill, this system efficiently sorts white fir and ponderosa pine boards into designated bins, ensuring smooth workflow and accurate inventory management. By automating the sorting process, the bin sorter reduces labor, increases efficiency, and helps prepare lumber for further processing, drying, or shipment. The sticker stacker is an automated system used to prepare freshly cut lumber for drying by stacking boards with small wooden spacers, called stickers, placed between each layer. This process ensures proper air circulation, which is essential for even drying in kilns or air-dry yards. At Collins Lakeview Sawmill, the sticker stacker carefully arranges white fir and ponderosa pine boards to prevent warping and defects during drying. By automating the stacking process, it increases efficiency, reduces manual labor, and ensures consistent lumber quality. Dry kilns are specialized chambers used to reduce the moisture content of lumber, improving stability and preventing defects like warping or shrinkage. At Collins Lakeview Sawmill, white fir and ponderosa pine boards are carefully dried in controlled temperature kilns, ensuring uniform moisture levels. This process enhances lumber quality, increases durability, and prepares wood for grading, planing, and final processing. Building a timber log garage is a rewarding project that not only provides a secure storage space for vehicles and equipment, but also enhances the aesthetics and functionality of your property. With the growing popularity of prefabricated DIY wooden garages, homeowners are increasingly choosing to construct these durable and visually appealing structures themselves. Before beginning the construction of a wooden garage, thorough planning is essential. Consider factors such as the size of the garage, based on the number of vehicles and additional storage needs, the location on your property, ensuring proper drainage and accessibility, the type of timber, typically pine or spruce, which are naturally resistant to mold and rot. A well-thought-out design includes structural elements that enhance durability, thick timber planks for stability, and wind braces to protect against harsh weather conditions. A solid foundation is crucial for ensuring the longevity and stability of the timber log garage. The foundation options include concrete slab, the most durable option, providing a solid and level base. One of the main advantages of a prefabricated DIY wooden garage is its ease of assembly. Most kits come with pre-cut interlocking logs that fit together seamlessly, reducing the complexity of construction. The key steps in assembling the structure include setting up the base frame. The first step is to lay out the base beams on the foundation, ensuring they are aligned correctly. These beams form the base structure upon which the walls will be built. Stacking the log walls. Prefabricated wooden garages feature interlocking logs that can be stacked layer by layer. This process involves aligning the first row of logs precisely on the base beams, stacking additional layers while interlocking the corners for added strength, using wind braces to secure the structure and prevent racking under wind pressure. Installing doors and windows. Once the walls reach the designated height, door and window frames can be installed. These should fit snugly into pre-cut openings, secured with appropriate fasteners. The roof is a critical part of the garage, protecting the interior from weather conditions. The steps for installing the roof include placing rafters on top of the wall structure, securing roof beams for additional support, installing roof panels, typically made of timber or metal sheets depending on the design, adding insulation layers if needed to enhance energy efficiency. Wooden garages naturally offer good insulation, but additional enhancements can improve comfort. Some finishing touches include sealing the logs to prevent water infiltration and improve durability, applying wood stain or protective coatings every 2 to 3 years to maintain the wood's integrity, checking for mold or rot regularly, and removing any signs immediately. A timber log garage can serve multiple purposes beyond just parking vehicles. It can be designed to accommodate a storage space for tools and outdoor equipment, a workshop area for DIY projects and repairs, a multi-purpose space with shelving units and workbenches. Many homeowners choose to divide the garage into separate zones, with parking at the front and a workshop at the rear, maximizing functionality. To ensure that the wooden garage remains in excellent condition for years, regular maintenance is necessary. Key maintenance tasks include inspecting the timber for any cracks or warping, reapplying protective stain every 2 to 3 years, cleaning the exterior and interior to prevent dust buildup, checking the foundation for any shifts or cracks that may compromise stability. Cross-laminated timber, CLT, is a highly durable and sustainable wood-based panel material made by gluing together multiple layers of lumber. This engineered wood product is gaining popularity due to its strength, versatility, and environmental benefits, making it a suitable alternative to traditional construction materials like concrete and steel. One of the defining characteristics of CLT is its exceptional strength and resistance to environmental factors. The thickness of CLT panels ranges from 50 mm to 250 mm, allowing for superior load-bearing capacity, which makes it highly resistant to earthquakes. Additionally, CLT exhibits excellent fire-resistant properties, providing enhanced safety in construction projects. Another significant advantage of CLT is its high insulation and airtightness. These features contribute to energy efficiency by minimizing heat loss, ensuring a comfortable indoor environment, and reducing overall energy consumption. This makes CLT an excellent choice for sustainable and eco-friendly building designs. Furthermore, CLT meets the stringent seismic standards set by the Building Standards Act, making it a reliable material for construction in earthquake-prone regions. The adoption of CLT also plays a crucial role in supporting domestic forestry development by increasing the demand for locally sourced wood, which promotes sustainable forest management and boosts the regional economy. CLT maximizes its unique properties by moving beyond conventional architectural concepts through a pattern order system. This approach allows architects and builders to develop optimized design proposals tailored to the specific needs of clients. By engaging in collaborative discussions, designers can streamline the planning and construction process, ensuring efficiency and precision in execution. CLT is particularly well suited for social welfare facilities as it effectively addresses community-based requirements. The material is most commonly used in the construction of two-story wooden buildings, providing an ideal balance between structural integrity and design flexibility. Additionally, the use of CLT enhances cost performance and shortens construction time through efficient coordination and prefabrication. This efficiency not only reduces labor costs but also minimizes on-site waste, contributing to environmentally friendly construction practices. A typical CLT construction project demonstrates the material's effectiveness and practicality. The total wood usage in such a project is approximately 120 square meters, with the total CLT usage amounting to around 107 square meters. The structure of a standard CLT building is a two-story wooden construction with a total floor area of about 301.08 square meters. This demonstrates CLT's capability to support mid-rise buildings while maintaining its environmental and structural benefits. Over 65 million people worldwide have been displaced due to conflict, persecution, and disasters, facing uncertain futures and inadequate living conditions. Millions endure overcrowded, unsanitary shelters with limited access to clean water, healthcare, and security, increasing vulnerability to disease and exploitation. Temporary tents deteriorate within months due to weather and wear, yet displaced individuals often remain in crisis situations for over 15 years. A safe and sustainable shelter solution for displaced populations. Designed for quick assembly, requiring minimal tools, labor, or expertise. Lockable doors protecting children and vulnerable. Durable materials allow disassembly, relocation, and reassembly for extended use. Made from eco-friendly materials that can be repurposed or recycled efficiently. Modular design allows enhancements like insulation, solar panels, and extensions. LifeShelter prioritizes local production, utilizing regional materials and labor to reduce costs, support economies, and ensure faster deployment. This approach fosters self-sufficiency, empowers communities, and minimizes environmental impact by reducing transportation needs and promoting sustainable building practices. Windhoek is home to Polycare Research Technology Namibia, a pioneering company based in Blackwater that manufactures polymer concrete building blocks as an alternative to conventional cement and clay bricks. This innovative approach to construction is transforming the building industry by offering a sustainable and efficient solution. Polycare's building blocks are made using a unique modular assembly system, MAS, which binds locally available materials such as desert sand, river sand, and ash. This method not only reduces dependency on traditional cement and clay, but also allows for the construction of various structures, including houses, schools, and clinics. The modular assembly system enables rapid construction, allowing a house to be completed within 2 to 3 weeks with minimal waste. Additionally, the pre-designed nature of the buildings facilitates easy expansion for future needs. The polymer concrete blocks produced by Polycare offer numerous advantages over conventional materials. They are significantly harder than traditional concrete and can be manufactured with exceptional size and shape precision while maintaining a lower weight. Unlike conventional bricks, these blocks do not absorb water, making them completely windproof, frostproof, and corrosion-resistant. They are also highly resistant to UV radiation and extreme temperature variations, ensuring durability in various environmental conditions. Another key benefit of these polymer concrete blocks is their built-in insulation. This feature helps regulate indoor temperatures, keeping buildings cool in the summer and warm in the winter, thus enhancing energy efficiency and reducing the need for additional insulation. A life cycle analysis study conducted by EURA has demonstrated that Polycare's technology is 60% less harmful to the environment compared to conventional cement-based construction. This significant reduction in environmental impact is attributed to the innovative use of locally sourced materials and the energy-efficient production process. The merchandiser in-feed is the first step in processing logs at the sawmill. Logs arrive from the yard and are fed into the system, where they are assessed for size, quality, and optimal cutting potential. Using advanced scanning technology, the merchandiser determines the best way to maximize yield while minimizing waste. Logs are then cut to precise lengths before moving into the sorting bins, ensuring efficient processing further down the line. After initial processing, the lumber undergoes species analysis, where advanced scanners and sensors identify wood type, density, and quality. This ensures each piece is optimized for its best use. The cut-to-length saws then trim the lumber to precise dimensions, maximizing efficiency and minimizing waste before further processing. After the merchandiser, logs are sorted into species and size-specific bins using automated systems. This ensures optimal processing, as different wood types and dimensions require unique cutting, drying, and milling techniques. Once sorted, logs move to the sawmill in-feed, where they are aligned and fed into the milling system. Precision conveyors and scanners ensure proper positioning for efficient cutting. This step maximizes yield by orienting each log based on its shape, size, and species before entering the debarking and sawing process. Logs are elevated and precisely aligned before entering the hew saw, ensuring optimal positioning for efficient, high-speed processing and minimal waste. After cutting, lumber exits the hew saw, sorted by size and quality, ready for further processing, trimming, or kiln drying. Processed lumber exits, sorted by size, quality, and use. Byproducts are reused for mulch, biofuel, paper, and animal bedding. Once the lumber is cut and sorted, rough or green lumber is carefully loaded into the dry kiln for moisture reduction. This process is crucial for stabilizing the wood, preventing warping, and preparing it for further processing. Lumber is stacked in uniform layers with spacers, stickers, between each board to allow for even air circulation. The kilns use a combination of heat and airflow to gradually remove excess moisture without compromising the wood's integrity. The drying time varies depending on species, thickness, and initial moisture content. Advanced monitoring systems ensure precise temperature and humidity control for optimal results. By properly drying the lumber, the mill enhances its durability, strength, and usability for various applications, from construction to fine woodworking. This step also helps prevent defects and prepares the lumber for final finishing, such as planing, grading, and packaging.